The late Cretaceous is often defined by an absolute rule, one massive predator standing at the apex of its food chain, so large that it seemed to leave no room for a rival. For decades, the fossil record appeared to confirm this isolation. An adult Tyrannosaurus rex relied on raw, bone-crushing force. On this scale, it was the only king the world had room for. Then, a different kind of artifact emerged from the rock. It was a compact, narrow-snouted tyrannosaur skull, only a fraction of the size of the famous giant. Researchers looked at the specimen and reached for the simplest explanation. This wasn't a new animal, they argued. It was just a teenager, a baby T-Rex caught mid-growth. That answer felt safe. It allowed the existing timeline of the Cretaceous to remain unchanged, but it also meant that for 80 years, an entirely separate predator sat on museum shelves under the wrong name. This proving the teenage theory was difficult, because young dinosaurs undergo drastic physical shifts. They don't simply get larger, their bodies warp as they mature. It was plausible that a narrow snout would broaden out to crush bone, or that slender runner's legs would eventually thicken into heavy pillars to support 8 tons of weight. This small skeleton became a foundational model. Paleontologists used it to write the textbooks on how the tyrant king grew from a hatchling into a monster. If those bones never actually belonged to a young T-Rex, then a significant portion of what we thought we knew about the life cycle of the king was built on a mistake. To find the truth, scientists looked inside the fossils. When a dinosaur grows, its bones lay down internal layers year after year, recording the animal's life history like tree rings. A juvenile dinosaur is in a race to get big. Its bones show wide, evenly spaced rings, piling on size every season. But as growth stops, the rings bunch up against the outer edge, showing the animal was mature and running out of room. Paleontologists Lindsay Zano and James Napoli applied this analysis to Bloody Mary, one of the most complete small tyrannosaur skeletons ever found. They counted roughly 25 cyclical growth marks, and in the outermost layers, they found those rings were closing in tight. This was an animal over 2 decades old. By the evidence of its own biology, it was done growing. A T-Rex at that age should have been a multi-ton giant. The fact that this specimen had finished growing while still small meant it was an entirely different species. While limb bones are the standard for these studies, a second confirmation arrived from a separate part of the anatomy, the throat. A team from Princeton and Yale focused on the hyoid, a tiny bone that helps anchor the tongue. The original 80-year-old skull didn't have limb bones to slice, but the hyoid provided a way to test for maturity without damaging the fossil. This chart shows the discrepancy. A confirmed teenage T-Rex throat bone contains only about 2 growth rings, but when they analyzed the famous baby skull, they found 8 tightly packed rings. The supposed child was, in reality, far further along in its life than an actual T-Rex teenager. 2 separate teams, using 2 different bones, reached the same conclusion. The dwarf tyrant was its own animal, not a child of the king. Formerly known as Nanotyrannus lithaeus, this dinosaur was built with a specialized design that set it apart from its heavy-set relative. It reached roughly 5 meters in length and 1,500 kilograms, a fraction of the mass of a 9-meter, 8,000-kilogram T-Rex. Despite its smaller frame, its arms were longer in absolute terms than those of the largest T-Rex ever found. It carried long, functional hands, tipped with hooked claws for grasping struggling prey. It stood on slender, elongated legs designed for a cursorial lifestyle. It was an animal built specifically for running. Even the skull was wired differently, with its own arrangement of nerves, and a narrow snout lined with blade-like teeth made to slice flesh rather than crush bone. Nanotyrannus traded brute strength for speed. It was a precision-based hunter that occupied a different world than the king. We have to reimagine the final million years of the Cretaceous as a contested landscape. The king was a slow, overwhelming bulldozer. It relied on ambush and pure force to bring down the massive prey that defined its era. But Nanotyrannus was a lightning-fast hunter. It ran down the smaller, quicker prey that the heavy T-Rex could never catch. Anatomy hints at a tense relationship between them. While the dwarf tyrant avoided the adult kings, it likely competed directly with the lean, fast-moving juvenile T-Rexes for the same kills. These 2 lineages existed side by side, splitting the ecosystem between speed and strength. Confirming Nanotyrannus means the diversity of predators at the end of the dinosaur age was much richer than the fossil record originally suggested. For exactly 80 years, we had one of the era's top predators sitting in a dusty drawer, simply labeled child. This mistake suggests a broader problem for the field. If such a distinctive, well-armed predator was misidentified for a century, we have to ask what else we have mislabeled. Other supposed babies of famous giants currently in museum archives might be their own forgotten species, waiting for a second look. The most obvious answer in science is not always the true one. The greatest discoveries often come from looking at the evidence we've had all along and seeing it for what it actually is.